Hi guys, this is Kalu Kechiko from solveme.com and I'm solving the UTME Mathematics 2011 questions paper type T, and this is question number 38. It says find the value of x at the minimum point of the curve y equals x cubed plus x squared minus x plus 1, and then we have the options here. So we've been given the curve already, so what we need to understand about curves is that curves have turning points. Since their motion is in a kind of a sinusoidal waveform, they have turning points, and those turning points can either be the maximum or the minimum turning point. So this is a quick diagram to show how the maximum turning point and the minimum turning point, how they occur. Before the maximum turning point occurs, the value of x changes positively. Then when it turns, it starts coming down and the value of x becomes negative. The same thing happens when it turns from the negative to the positive, and at that point we have it to be the minimum point. Now at the point where the value of x kind of tries to follow the y-axis in the perpendicular and then the x-axis in the parallel form, we call that a point of inflection. After a little steady movement, it still goes up, and assuming it was coming down, after a little steady movement, it still comes down. So we need to understand that at a stationary point, the y dx is equal to 0. So at every turning point, let's say we throw something up, you see when you throw something up, it gets to a certain point, then it starts coming down. At that point where the thing stops and it starts coming down, that point they change, the y dx is equal to 0. And at the maximum point, the y dx changes from positive to negative. So it changes from positive to negative at maximum, and at minimum it changes from negative to positive. But at the point of inflection, the sign does not change. So let's find the value of x at the minimum point of the curve. For us to be able to find this, we need to find the y dx of this curve, that is the turning point. We know that the y dx will now be equal to 0. So the y dx of the equation above, just differentiating it with respect to x, when we differentiate x cubed, we are left with 3x raised to the power of 2. When we differentiate x squared, we are left with 2x. When we differentiate negative x, we are left with negative 1. And when we differentiate positive 1, it's a constant, so it's 0. So we can now form our equation and have that 3x raised to the power of 2 plus 2x minus 1 is equal to 0. So for us to determine the turning points, we need to solve the quadratic equation. So we can use any method. We have the formula method, we have the factorization, but I prefer the factorization method since it's quicker. So the factorization method, we have 3 multiplied by negative 1, we have negative 3. So we have our factors of x. From there, very quickly, we have that the factors of x are 3 and negative 1. So we see factors of x are 3 and negative 1. If you don't understand the factorization method, you have to look up the video for factorization so you can follow, or you can actually apply maybe the formula method if you are conversant with that one. So the next thing we do, we solve this equation, and it now becomes 3x raised to the power of 2 plus, we have 3x here, we have minus 2x, we have minus 1 is equal to 0. So we factorize here. So when we factorize, we're going to be left with 3x in brackets, you're having x plus 1, and then we have minus 1. We factorize this part, then we have x plus 1. So we now have that 3x minus 1 is equal to 0, or we say that x plus 1 is equal to 0. So we have from the left hand, for this part, we know that x is equal to 1 over 3, or for the other parts, we know that x is equal to -1. So now we found the turning points. We know that the curve turns at point x equals 1/3 and it turns at x equals -1, but we don't know which point is the maximum and which point is the minimum. So we say determining the minimum and maximum points. Now we have two major methods of doing this. We have the neighborhood test method, and then we have the second derivative method. So I'll be using the neighborhood method since it kind of has a wider application. So I'll say applying the neighborhood test method. Okay, neighborhood. Alright, so for us to apply the neighborhood test method, we need to find okay, in a case of x equals -1, we need to find a value very close to -1 that is less than -1, and another value very close that is greater than -1. So we know that in the number line, -2 is less than -1, -3 is less than -1, and then 0 is greater than -1, 1 is greater than negative. So we can say for okay, testing for x equal to -1, we can use x equal to -2. This is less than -1, and then okay, let me write less than -1 here. Then I also have and x equal to 0, that is greater than -1. So in the neighborhood test, we are using very close values that are less than and greater than the value of x. So now let's make our substitutions. So from this here, we are substituting the values here. So we're gonna be having 3 brackets. We have -2. We are using for the value less than now, -2 raised to the power of 2 plus 3 raised to the power of -2 minus 1. So when we solve this, we're going to be having 3 multiplied by 4, -2 times -2 is 4, 4 multiplied by 3 is 12, and minus 3 multiplied by 2 is 6, then minus 1. So 12 minus 6 minus 1, we're going to be having 7. So we test for the greater than, we test for x equals 0. So to do that, we have 3 here, we have 0, then squared, plus 3, we have 0 here too, now minus 1. So 3 raised to the power of, okay, we see here everything 0 0, and we're left with -1. So we see that the sign changes from positive to negative. So we say for x equals -1, the sign changes from positive to negative. Therefore, let's look at our conditions. When it changes from positive to negative, that means that is a maximum point. You can therefore say that for x, therefore this is a maximum point. So we don't even need someone to tell us that 1/3 is the solution, but let's confirm. So now we we have testing for x equals negative, okay, x equals 1/3, sorry, x equals 1/3. So we're gonna have to find values that are very that's less than and greater than 1/3. So let's use x equals 1/4. This is less than 1/3. Then and x equals 1/2, that is greater than 1 over 3. So we have 1 over 2 here, that's greater than 1 over 3. So we do substitution just as we did here. We have 1 over 4 inside here, raised to the power of 2. Now we say plus 2 brackets 1 over 4 minus 1. So when we solve this, okay, when we solve this, we're gonna be having 3 over 16 plus 1 over 2 minus 1, and that will be equal to negative 5 over 16. So now let's test for x equals 1 over let's test for x equals 1 over 2 now. So for x equals 1 over 2, so as the greater part, we are having 3 brackets 1 over 2 raised to the power of 2 plus 2 brackets 1 over 2 then minus 1. So we solve it arithmetically, and then we are going to be left with 3 over 4. So we see that this changes for x equals 1 over 3. It changes from negative. We see here we have a negative 5 over 16. So we say for x equals 1 over 3, the value changes from negative to positive. And from what we have here, whenever it changes from negative to positive, that is a minimum point, and it says find the value of x at the minimum point of the curve. Therefore the value of x at the minimum point of the curve is 1 over 3, because we found out that at x equals 1 over 3 the point is minimum. So 1 over 3 is our solution, and that is option A. So if you have any question based on this particular solution, you can leave it on our comment section below. But if you have any other general mathematics question, you can leave it on our website www.solveme.com, and it will be attended to. Thank you very much, and have a nice day.